I plan to perform a controlled experiment on Claude Code in this video. I will push Claude over the edge to show you where it ends. The hype is still alive. Non-credible stories of Claude's fame and might may confuse you. The truth is simple. Claude Code operates on an LLM which can write code but cannot do the software design. I have discussed those limitations of LLMs in other videos on this channel. You will now witness Claude do both design and implementation. I know the result because I see it every day at work. Still, I must show the entire experiment to counter the videos where fairy tales blossom and AI taking our jobs is a done thing. The reality is far from that simple. So the experiment. I will show you a small proof of concept application. It mimics my real project from last week. The problems are 100% realistic. We are developing a web application storing large binary files of various kinds. A new request will be designed and implemented by Claude Code. Then the complexity sneaks in. Different files need different decoders decided by the file's header. All files contain the same kind of data, only the encoding differs. That is how YouTube works, and it always streams the version appropriate for your device. Now comes the new requirement. We will implement algorithms applying uniformly to all files irrespective of encoding. The immediate task is to develop infrastructure that makes it easy to add new algorithms. Isn't that a wonderful job for a developer? Abstracting things out, crunching bytes. I could do that all day long, but I will let Claude have that pleasure today. Very briefly, I'll show you the proof of concept application. This abstract record defines supported file formats. There are two dummy representatives just to satisfy the requirements. There is a small class that decodes the format from a given stream. In the production application, specialized classes like this one read file headers and decode the format very efficiently. Let me briefly run the application and the rest will be Claude all the way to the bottom. It isolates C# files in the local directory, pretending to read each one's encoding. 3 files appear as format A, the 4th as format B. Claude will read this code and try to extend it. There are 2 dummy decoders in the model. They only pretend to work, but their method signatures match the production application's intention. Some decoders decode the data in blocks. Format A decoder does that. Please read the signature. The method receives a buffer to write decoded data into. Still, the buffer's size is dictated by the format, not caller's decision. The other larger group of decoders operates on sequential content. There is no block to read from the consumer's perspective. Deflate algorithms work like this even when the compressed file has blocks inside. The nuance is that you can now read the data 1 byte at a time, which is an extremely inefficient I/O strategy. You will invariably read in blocks, but then you choose the block size and the decoder should adapt. All this matters because that is the world Claude will extend. And now the twist. I constantly read in the comments, wait for the next AI model, it will fix the problems. Therefore, in this video, Its Majesty, the next model. I will use Claude Fable to show it failing as miserably as Claude Opus recently did on the same production requirements. Let me clarify how this experiment will progress. The problems I will show you live at the heart of every LLM, so don't tell me the next model will fix this. It will not. I bet my money that no new model will fix this in the next 5+ years. The model that overcomes these limitations will not be an LLM. Such models maybe exist in laboratories or at the academia, but they are years from practical use. Now, let's put Claude Fable in motion. A Claude MD file already explains the architecture and technologies, giving Claude sufficient context. We can get straight to the point. There is a new requirement to process the files by running an algorithm on their content. Then come the technical requirements. Each algorithm operates on the decoded content, not on raw file content. Several algorithms will exist and more will come over time. Now an important constraint. We know that all algorithms will operate sequentially single-pass forward only. That confirms the current storage strategy suffices, so Claude won't reconsider storage decisions. Another important consideration. Some algorithms will be CPU intensive. There will be a demo algorithm to try the new implementation out. The demo algorithm will return the average byte value from the file. Simple and effective for demonstration. I won't tell Claude how to do its job, but I will fairly share the information known to me. Files on the server are typically a few megabytes, but we support up to hundreds of megabytes. Decoding a file may expand it in size. Some file formats are compressed. Never forget, the web server runs multiple concurrent requests sharing CPU but also memory. A large memory footprint means even a moderate number of consumers will topple the server. This is all I wanted to tell Claude. Produce the design that supports these requirements. Ask whatever questions you need answered. Do not write any code before I confirm the design. I believe you have a good grasp of what I want, and Claude will too, so I am running it. The process is lengthy. Nearly a minute later comes the questionnaire. When does an algorithm run? The first answer offered is correct. Algorithms are always triggered explicitly by the web request. The next one is interesting. Should one decode pass be able to feed several algorithms at once? No, I already see a few counterexamples. I will choose one algorithm per pass. Now this question is interesting. What happens to an algorithm's result? Are result types heterogeneous? Yes, all kinds of results, and they are invariably returned to the caller. It seems Claude has no further questions. Let me unleash it once more, and it should now run until it produces the design. This run takes much longer, and I will cut it out from the video. After 2.5 minutes of total thinking, Claude has produced the output. There are a few screens full of text here. Let's read it from the start. The first block reiterates the context. Decoded content is too big to materialize and must flow in small pieces. Decoders are heterogeneous and something must reconcile the two shapes. I/O is async and fetching should stay separate from processing. All correct and a good starting point for the design. Claude starts from the definition of an algorithm. An algorithm accepts one chunk at a time and processes it without telling the result yet. The result comes only after the outer loop passes all chunks in. Now, what do you see here? An abstraction of a data crunching algorithm? It implicitly forces callers to chunk the data. That may look good, thinking about performance at the outset. Did Claude do a good job with this abstraction? No, it did not. Claude only fell into the premature abstraction trap typical of junior programmers. How on earth did it invent an interface with not a single implementation? The result is a complete inversion. An imaginary outer engine feeds the algorithm. Even the section header says it clearly. A push-based accumulator. Who says that is a good idea? Did it ask for confirmation? Did it consider pros and cons? Here is the con I see. An algorithm that could finish early would still wait for the whole file, wasting the decoding of hundreds of megabytes for nothing. That is a blunder Claude cannot see. It fails in ways no human programmer fails. Remember that when correcting it. The other problem looks tiny now. How can you design an interface before writing a single working class? What would you be abstracting? Let's continue. The next section defines a decoder. Another beautiful abstraction serving an async stream of byte blocks. Two things. Why send multiple buffers when the caller uses one at a time? An experienced programmer would reuse one buffer or let the decoder write directly into the output, saving needless copying. This application is all about performance, remember? Second, this design closes the door on future seekable decoders, which are easy to imagine. The first two sections brought two long-hauled decisions that limit my future abilities. Those are mistakes an experienced developer would never make. Then comes the decoder selection. Claude thought about choosing a decoder, but all known formats are hard-coded. More formats might come, so why not register the detectors and decoders? Pattern matching is the wrong tool here, limiting my future decisions again. 3 sections so far, and 3 times Claude fell into the trap. Then the orchestration section where all bad decisions materialize. There is an explicit engine that runs an algorithm. It cannot account for future seekable decoders, preemptive algorithms, or different formats. This entire class is unnecessary at this stage. Some form of it might emerge much later, but not now. The demo algorithm section comes next. It is the victim of the design and not its driver. I'll walk past it. Then a beautifully formatted section explains how past decisions shape concurrency and CPU load. This is one really well-structured essay. The problem is in the past decisions. I need not read it. The bad consequences are already clear to me, but not to Claude. Alternatives considered and rejected. Now this is interesting. The second point says the pull design was rejected because it hands buffer management to every algorithm. Well, no, that is not how it happened. Claude didn't get buffer management right at first, and the avalanche of bad decisions followed. That's how I see this, and we will return to this point again. Now you make the verdict, and the verdict depends on how experienced you are. That is the worst part of working with AI tools. Claude's analysis is astonishingly detailed and verbose. A less experienced developer would trust it, overwhelmed with the level of detail. I mean, how can such a report be wrong? It takes years of experience to see that everything Claude wrote here is just rubbish. A total worthless rubbish. The proof of concept I gave it at the beginning was open to numerous optimizations and future features. Claude's design closed the most promising paths. Now begins the second part, where I take the lead and Claude follows. Imagine an experienced software developer stepping into the room. I will now show you how I communicate to Claude in my private quarters. First off, this design is not good. Forget the design you made, but not the requirements. Requirements stay. We are restarting the process. This is how you will behave from now on. I give the design in small chunks. You give the opinions. This acknowledges Claude is very useful in analysis. It often finds holes in my logic and missed corner cases. That is where I let Claude operate freely. Never write more than 300 characters in one response. When Claude fills the screen, chances are near 100% it has lost direction and is producing the next pile of rubbish I must clear. You will do the implementation in small controlled chunks. Confirm. I want to see how it responds now. There, 3 seconds of thinking, not 3 minutes. It's ready for the first bit of information. You are right about asynchrony. Data must be fetched asynchronously and in batches, which tells me the file decoders in the proof of concept are wrong and must be fixed. Let's see what Claude has to say. It thinks a little longer this time, but far shorter than before. 11 seconds, and here is the response. It complains about the length of the buffer I wrote. That means Claude has not understood this is a demo. 16 bytes is right for the demonstration. Production-ready solution is not here yet. Do you see what I'm doing? I add one piece of information at a time to see when Claude drifts. Each interaction takes seconds, yet I already corrected one damaging silent assumption. Now we start from the decoder abstraction. The decoder owns the buffer. That was Claude's greatest omission in the first round, which it made single-handedly and without asking for my judgment. Let's see what it says now. Oh, it agrees with me, it says it's reasonable. Now, how come it wasn't reasonable when Claude decided against it? That is what I keep saying about LLM-based AI tools. They don't have reason. They cannot see the difference between the two approaches. Experienced developers see it with all the consequences. Block decoders determine buffer size. It directly depends on the file format. Claude confirms my thinking again. Claude is good at finding blind spots, and this process provokes it into finding my mistakes. So far, I have passed the checks. Streaming decoders may receive the buffer size from the caller. Claude thinks and comes back with another confirmation. It says the design is consistent, and my own thinking confirms it. Every decoder exposes a read-only span with the buffer content. That completes buffer ownership. Callers get read-only access to data chunks. 7 seconds later, Claude confirms the strongest point in my design. This idea closes the gap between asynchronous I/O and synchronous CPU-bound processing. Then it corrects a mistake I made, reminding me that read-only span is not an interface. Thank you. Claude readily catches any logical, structural, or algorithmic mistake when fed one sentence at a time. It corrects you or makes you reiterate decisions until they are consistent. I rely on that ability a lot. Now the details. Asynchronous read method returns number of bytes read. Let's see what Claude says. It looks like it agrees. Now decoder reuses the same buffer, only the last chunk might require resizing. A much stronger performance guarantee than what Claude came up with. Decoder must be disposable. Claude never mentioned this in its design. Concrete decoders will hold resources that require disposing of. A related detail, the decoder never disposes a stream. Streams are owned and disposed by the caller. Then we draw a line. Is this sufficient to define a sound and complete decoder interface? This signals Claude to analyze all the requirements once more. It says yes, so we proceed. Only define the interface, do not implement it yet in concrete classes. That is when I let Claude write code. We made numerous decisions together, and I would even feel safe letting it complete the implementation now. Once you correct Claude's silent assumptions, it generally produces a correct implementation. Still, I just let it write this single interface, which I did. In practice, I would write the interface myself and let Claude infer my intentions. That would be faster. Anyway, I like that it added the cancellation token, which I never mentioned, and that it returns value task. That shows attention to performance, just as this application demands. That leads us to the ultimate demonstration of the point I wanted to make about Claude's capabilities. Provide a correct implementation of this interface in format A decoder. While Claude thinks, let me restate my point. Claude is deeply incapable of extending software, of design and architectural decisions, or decisions of any kind if you like. The reasons are entrenched in its architecture. No new version will fix them. Leave your hopes here. But then comes the bright side. If you do the design instead, based on your knowledge and experience, Claude will follow and make those ideas even better. And it will eventually implement them near perfectly. But remember, only after all decisions are made and confirmed. Let's see the class and complete this demo. I see one very interesting improvement over my design. Claude returns a slice of the maximum buffer, avoiding the additional reallocation completely. It detoured from my explicit instructions. That may be dangerous, so better check what it did. But here, Claude wrote code better than I would. I hope you now see how Claude operates. Claude is not a software development tool, whatever people tell you. It is way below the bar in software design. Its mistakes are costly and hard to correct. The steering wheel must remain firm in your hands, but once you do the steering, Claude will suddenly turn into a beast. It will analyze your requirements closely, correcting your inconsistencies at every step, and it will likely write excellent code on the agreed design. I have shown you the way, the rest is up to you.